Hey guys, welcome back. Hope you all are doing well. This is Mohammad Badruddin back again with the last lab of HTTP request smuggling vulnerability module. In today's lab, we are going to see server-side pause-based request smuggling. The description of this lab is saying this lab is vulnerable to pause-based server-side request smuggling. The front-end server streams request to the backend, and the backend server does not close the connection after a timeout on some endpoints. On some endpoints, not on all endpoints. Okay. To solve the lab, we need to identify a pause-based CL0 desync vector. Then we will smuggle a request to the backend to the admin panel at the /admin, then delete the user Carlos. The most important note here is some server-side pause-based desync vulnerabilities cannot be exploited using Burp's core tool. So we will use here Turbo Intruder extension. Okay, we already open up the lab here. Burp Suite is working. So, okay. All the request goes. I need to actually clear a few things here. So I don't need all these requests. I'm gonna delete it. Fine. So here we have the web root request, and we have here another request which is static resource, that is /resource endpoint, and within that /resources endpoint we have images avatar. Within this endpoint we also have JavaScript files, but I need this static resource. Okay, so what I'm gonna do, I'm gonna send this request to the repeater. So before going further, I need you to know few things, like for web infrastructure to be vulnerable to a server-side pause-based attack, 3 specific architectural conditions must be met. The first one is immediate forwarding. What is immediate forwarding? The front-end server must stream request bytes to the backend as they arrive. If the front-end server waits to receive the entire request before forwarding anything, the attack fails. So this is the most important condition 1. The condition 2 is mismatched timeout between the front end and backend server. So this discrepancy must also be fulfilled for the successful attack. So the backend server must have a shorter read timeout than the front end server. And the third condition is connection reusability. Means when the backend server times out the initial read, it must leave the connection open for reuse rather than terminating it. So these 3 conditions must be met. Now, because the lab is already saying that this vulnerability exists and we need to find it and exploit, that means we are going to use this. Okay, so okay, go back to the repeater here, and if I just take out everything after the resources endpoint, here we just have /resources. If I send the request, you will see the response is redirecting us to the /resources/. And this is what we need. Okay, so what I'm gonna do here is change the request method to post, and I don't need all of these things up to the cookie. One more thing I need to put here is connection header. As I mentioned before, that connection reusability must be there. So we will put the connection keep alive. So keep alive. Okay, this is the very first thing. Second thing, let's say if I just send the request, let's see if the request is successfully processed and we get the normal response or not. Fine. One more thing to be noticed here, it's using Apache 2.4.52, and that version of Apache does have this vulnerability, which is CL0. Okay, so what I'm gonna do here, normally once we test this vulnerability, so what we do, we have here another smuggled GET request. So I'm gonna put here a GET request / let's say anything, and HTTP /1.1, and then I'm gonna add here anything, let's say fake header. Okay, sorry, fake header. And one more thing, go to the request attribute and degrade the HTTP protocol to version 1.1. Fine, send the request, and you will see we get exactly the same result and very normal result. The problem here is we will not get the response as we got in the previous labs, where we send the smuggled request, attack request, and send again the normal request or the same request, and we found 404. Okay, so for this purpose, as it mentioned in the lab, that the burp score tool will not work in such kind of special cases like server-side pause based desync vulnerability. So for that purpose, we need to use the Turbo Intruder. Okay, so basically we need to access here admin panel, but I will do that later. First of all, we need to identify the desync vector, and for that purpose I'm gonna right click and go to the extension, go to the Turbo Intruder, send to Turbo Intruders. Fine, and here I already have this here, so I'm just going to change it to anything, and here I don't need this now, we will use this later. Basically we will use this Python script, and to save the time I basically took it from the lab solution. Okay, and what we are just trying to put here the pause time up to 61 seconds. Okay, because the backend timer or backend timeout must be less than the front end timeout. So let's see, here I need to put 2 more turn line feeds, what we did here, and just attack. Make sure you change the concurrent connection to 1, and request per connection is 500 or 200 like this. Just send the attack, and you need to wait up to 61 seconds because we make the pause 61 seconds. So duration here you can count the seconds, and once the 61 second is completed, we get here the response. So we get here 2 responses. Basically you can see this is the very first request what we sent as the post request to the /resources, and the response is expected. You can see it is redirecting us to the /resources/ location, and we have another request, and this request is also saying 302 found, and it's sending us to /anything. Okay, fine. So it's adding /anything/. Actually we should do something like this to get the correct response. Okay, we should get the 404 not found in the second request. Okay, so make sure you do everything, you check everything before you perform this attack. 55 seconds, 57, 58. Okay, so you can see the first request have 302 status code, which is redirecting us to /resources/. This is expected, and in the second request we got 404 not found because this anything does not exist. Fine, so this confirms that the lab is vulnerable to HTTP request smuggling CL0 desync. Now the next step is we will try to access the /admin panel. So if we go back to our lab here and we try to access /admin, okay, it's saying the path /admin is blocked. Fine, so let's see, if I go to the Turbo Intruder and I'm gonna add here admin. Fine, and instead of this fake header I'm gonna add here host, and we will add our genuine host, copy and paste that here. One more thing, make sure two turn line feeds are here. So we have the pause marker and the pause time is 61 seconds. So this is perfectly fine, and we will try to access /admin to this. So let's see what this will give us. One more thing I forgot to mention, because we change all of these things, like we change the host header, also anything. So the content length must be changed. And for that purpose, I'm just going to take this, copy back to our burp repeater and add it here, add two turn line feeds. Now we need to see how much the content length is, which is 89. So if you send it, it will automatically update it, and yes, 89 is the content length. So in the Turbo Intruder, we must update this. So 89 is the content length, and rest of the thing seems perfect. Now let's just configure it and attack. Again, we have to wait up to 61 seconds, and then after 61 seconds we get the request here. Okay, this is perfectly fine. You can see the first request 302, which is redirecting us to the resources /, and the second request we have 401, which is the /admin. But if we see the response here, this is the response for the admin page once we try to access the admin page. And here it's saying admin interface only available to the local users. This is good. So that means only local user. That means we could try to access the admin panel on the local host. Okay, and we will do that here in the configuration section. And in the configuration section, I made one more mistake. Basically, I forgot to do that, which is connection keep alive. Because as I mentioned that there are three conditions to be fulfilled, in which the last one was the keep alive connection or reusable connection. And for that purpose, I need to add here another header, connection keep alive. Okay, that seems fine. And here, instead of this header host value, I'm gonna say localhost. Okay, and I'm going to take this back to our burp, and I'm going to update it here so that I can get the exact number of bytes for the content length. It is 41. So back to Turbo Intruder, 41, and wait, there must be one more turn line feeds, two turn line feeds. Okay, 41. Yes, fine. So let's go and attack one more time. Again, we have to wait for 61 seconds. Okay, so 61 seconds are completed, and you can see the first request as we expected, redirecting /resources/, and the second request, this time 200. 200 means there is a good news, because we successfully accessed the /admin page. So if I scroll down, we will find here admin panel. Okay, so admin panel is there, my account is there, and there is a form. So this is the form. The request method is used is post, and the action, it is gonna take over this endpoint /admin/delete with a CSRF token. Okay, and another field here, another input field here is username. So using post, I'm going to just take this, Control C. I'm gonna open a mouse pad and paste it here. This is important, and we can basically create the request here, and the request must be like post /admin /delete, and we must put here one more slash. Okay, http /1.1, then host header must have localhost, because the admin panel only allowed for the local users. Then we need to have the content length and the content type, so we are going to take that from here. Okay, content length and content type, copy back here, paste that. Okay, we don't need this application, we just need xwww form URL encoded, and then we need to pass here CSRF token as the body section, body data. So CSRF is equal to, what is the value of CSRF? This is the token, copy, paste that. And another parameter is username. So username is equal to, what user we want to delete is Carlos. This is what is going to be our smuggled request. I'm going back to the Burp Suite and just paste it here. Now again we need to just calculate the body section data. So here it is 53. We need to update the content length here to 53, and then I need to see how much data we have here. The number of bytes here 159, right? Yeah, 159. Just make sure everything is correct, because you need to wait another 61 seconds if this is wrong. Fine, so I'm just going to add this, copy, come back to the Turbo Intruder, paste it here. Fine, and update it to 159. That's it. Now another important thing is here, because the content length, we put another data here, because this request, what we tried to smuggle before, was the get request. So there was no body section or no body data. For that we don't have content length before, but now this is the post request and it also has its own body data. So we need to update here the content length also, which is going to be 53. So I'm going to take this and paste it here, sorry, inside this single quote. And then we have two turn line feeds, one after this and one is here. Then we have this data. Fine, so seems perfect. Let's just attack. Let's just manage this a bit so that if the lab is solved, we can see side by side. Okay, and the lab is solved. So you can see the first request is 302 found, and the second request is to delete the Carlos user account. Okay, and we solve the lab. So that's it for this video. If you like the content, please like, subscribe and share. This was the last video of this series, HTTP request smuggling. Next series we are going to start for the Active Directory. So we will see Active Directory attack and defense series in the next coming video. So see you in the next video. Bye.